Hi. What we will do now is that we'll revise the fourth theorem, which is basically, okay, that if two sides of a triangle are equal in measure, the side of the opposite angles, the angles opposite those sides are also equal in measure. Now this is absolutely crucial theorem, lads, basically because this is the first theorem that involves congruent triangles. And congruent triangles are so important in terms of a junior cert higher level course. What I want to do is briefly go over two things in which congruent triangles are important, okay? The first thing in relation to congruent triangles is basically, how do you know that two triangles are congruent? How can we prove that two triangles are congruent? How can we show that two triangles are congruent? And there are four ways. The first way, lads, is that if you want to prove that two triangles are congruent, basically what you have to do is look first of all at the sides of the first triangle and see, are they equal to any side in the second triangle? Okay? Now if we can show that the three sides here are equal to three sides over here, then those triangles are congruent because of side, side, side. But again, what's important, lads, if you make the statement, for example, that AB, that the side AB is equal in measure to the side MP, right? That AB is equal to MP, you must state that it's equal, but you must equally give a reason why they're equal, and that's crucial. But if three sides equal three sides, they're congruent because of SSS. The second reason why they could be congruent is if we can prove that two sides and the angle in between them in one triangle are equal in measure to two sides and the angle in between in the second, then those triangles are said to be congruent because of SAS, side, angle in between the sides, and side. Any problems there from anybody? Okay, the third reason why they could be congruent is because of angle, side, angle. If two angles and the side in between them are equal in measure to two angles and the side in between them, then they're congruent because of angle, side, angle. RHS is the fourth and final reason, that if basically the right angle, if you have two right angle triangles, if you can show that the opposite side to the right angles are equal, and as we know, lads, the side opposite a 90-degree angle is called the hypotenuse. So if the two hypotenuses are equal, and if one other side is shown to be equal, then the triangles are congruent because of right angle, hypotenuse, and side. Any questions about that, please? Okay. Now if we look very quickly at the theorem itself, what are we given? Again now, lads, we are given a triangle ABC with AB equal in length to AC and angles 1 and 2 as shown. Now remember, lads, angle 1 is opposite one of the equal lines, angle 2 is opposite the second equal line. So we want to prove that those two, because the two sides AB and AC are equal, that angle 1 is equal to angle 2. What is our construction? Our construction, lads, is basically that we draw a line AD from A to point D. Now what you know is two things, okay? Number one, that angle D is on the line BC. So you say that D is an element of BC. And second of all, you can say that the line AD bisects the angle BAC. Now the common mistake here, lads, okay, is that people say that AD is perpendicular to BC. It's not. You're not told it is. It's not a fact that it is, so you cannot put down that it is. You know that that line bisects the angle, which means that it cuts it in two equal parts. So therefore those two angles are equal. Now what we're going to do is to look at the triangle ABD, the triangle ADC, and see, are they congruent? proof, lads, is the following. Okay? If we look at those two triangles, we can say that if we look first of all at the sides of ABD and ADC, AB is equal in length to AC. We state that because it's given. We're told that in the question. Statement number 2 in relation to the sides is that AD is in both triangles. So we say that AD is equal to AD because they're common. Now, is BD equal to DC? It could be, but we can't give a reason why it's equal, so therefore we can't state that it is equal. Any questions about that now from anybody? Okay, so what we're looking at then, lads, is the angles. We know that, basically, that x is equal to x because we're told that D bisects the line ABC, sorry, the angle BAC. So x is equal to x because it's given. Now let's look, lads, are those triangles congruent? They are. Why are they congruent? Because if we look at the board again, they're congruent because SAS, two sides and the angle in between are equal in both triangles. That's the case here. Two sides and the angle in between in ABD are equal in measure to two sides and the angle in between in the triangle ADC. Therefore, they're congruent because of SAS. Now, what it means if they're congruent is that corresponding sides and angles are equal. And corresponding, two angles are corresponding if they're opposite the same equal angle. Sorry, two angles are corresponding if they're opposite the same equal side. And we know that AD equals AD, therefore angle 1 is corresponding to angle 2. And because the triangles are congruent, corresponding angles are equal to each other. Therefore, angle 1 is equal to angle 2. And the theorem basically then is proved that in an isosceles triangle, the measure of the angles which are opposite the equal sides are equal. Any questions, please? Okay, thank you.